Hi everyone, congratulations, you've officially made it to the last lesson of the conic section unit, and today we are going to learn about how to graph and write equations of hyperbolas. A hyperbola is simply a parabolic looking shape that occurs twice. So we're going to have two parabolas that we're going to draw on the same grid. This type of lesson has a lot of setup for it, in order to graph, there's a lot of setup. So before we actually draw our hyperbolas, there's going to be a lot of things that we need to draw onto our grid in order to make sure our sketch is accurate. But that's something that we're going to get into in just a moment. Before we get started though, I would like you to please complete this really quick warm-up. The warm-up is the point -2, 4 lies onto a circle centered at -5, 2. Write the standard equation of the circle. So go ahead and pause the video, and if you need to refer back to 9.3 a couple sections ago, that is not a problem, but I want you to pause the video and answer this question. When you are finished, please restart the video. Let's see how well you did. Here we go. So the standard equation of a circle, whenever it's not centered at 0, 0, is going to be the equation of x minus h squared plus y minus k squared is equal to r squared. So based on the information that's given to us, I know what x and y are because that's a point that's on the circle. And I even have my h and k, but what I don't have is my r squared. So that's what I need to find. I need to find what r squared is. So what I'm going to do is I'm going to substitute all x and y values and h and k values into this formula. So x is going to be -2 minus h, so minus -5 is going to be plus 5 squared, plus y, which is 4, minus k, which is 2 squared, equals r squared. -2 plus 5 is 3. 3 squared is 9. Plus 4 minus 2 is 2. And 2 squared is 4. And this is equal to r squared. So 9 plus 4 is 13. And so 13 is equal to r squared. So my equation is going to be x plus 5, so that's x minus -5 squared, plus y minus 2 squared equals my r squared, which is 13. And that's my answer. So hopefully your answer matched up with my answer and you did a really good job. So now we are ready to draw hyperbolas. So I'm going to use the space below to kind of talk about some generalities between hyperbolas. First of all, the general form or the general equation for a hyperbola is going to be different than an ellipse. So this is going to be, but kind of looks similar to the equation for an ellipse. It's going to be x squared over a squared minus y squared over b squared equals 1. Or it's going to be y squared over a squared minus x squared over b squared equals 1. So there are two different equations, and both of these equations will produce different looking graphs. So let's say that x squared comes first. If x squared, the part that has the x squared, is first, then that means that our hyperbola, so remember I said in the very beginning of this lesson, it's like you're going to be graphing two parabolas. Your hyperbola is going to look like this. It's going to be horizontal along the x-axis. You're going to have two parabolas that you're going to be graphing back to back. So then this is what your graph will look like. It will, your hyperbolic shapes, or it kind of looks like a parabola, but your hyperbolic shapes will be pointing to the left and right. along the x-axis, because x squared came first. Or if y squared comes first, so if y squared is first, then your hyperbolic shape, or your graph, your hyperbolas, will be along the y-axis. So it's going to be pointing up and down. So we're going to be graphing both at the same time, so up and down. And this will be along the y-axis. So to know which shape we're going to be graphing, it just depends on which is coming first. Is x squared first, or is y squared first? So what we're going to be doing is, like I said, there's a lot of setup, but there's going to be no tables, which is kind of nice. It's just a lot of setup for graphing these. And the graphs are going to be essentially sketches, fairly accurate sketches. So here we go. The first thing we want to do is we want to make sure that our equation is written in the form that we need. And that means that it needs to equal 1. So I'm going to divide both sides, every single term on both sides, by 36. And by doing that, we now have x squared over 4 minus y squared over 9 equals 1. So now it doesn't matter that 9 is bigger than 4, because x squared came first and is positive. That means that our graph is going to be pointing to the left and right. So it's going to be pointing to the left and right, which means that the x-axis is our winner. It's going to be along the x-axis. Now, just like we've had in the past, where you've seen x squared and y squared alone, our center in this case is going to be located at 0, 0. There is no h or k that we have to worry about in this problem. So our center is simply going to be 0, 0. And we can plot it right now. I'm going to go ahead and start by plotting 0, 0. Please know, though, that none of our hyperbolas, all of my pictures that I showed you down here, notice that none of them went through 0, 0. Yet 0, 0 is considered our center point. And that's because it's going to help us to try to come up with our actual shape, our accurate shape. Now your vertices, because it's along the x-axis, even though 4 is smaller than 9, 4 will be where our vertices is. So in order for me to find what A is, I'm going to take the square root of 4, and that's going to be 2. And the square root of 9, that's going to be 3. That's going to be B. So what I'm going to do is this. I'm going to start at 0, 0, and I'm going to count 2 units to the left and 2 units to the right. I'm going to count, and I'm going to come up with those ordered pairs. And those ordered pairs are going to be 2, 0, and negative 2, 0. So those are my vertices, 2, 0, and negative 2, 0. Now, the other co-vertices, I call them pretend co-vertices. So they are pretend. I don't know why it's a capital T, so just forgive me on that. So these are pretend co-vertices, and that's because of the fact that nothing is really going to go through them. They just help us with the structure of our graph. So our pretend co-vertices is going to be based on the 3. So I'm going to go back to 0, 0, and I'm going to count 3 units up and 3 units down, and identify what those ordered pairs are. Those ordered pairs are going to be located at 0, 3, and 0, negative 3. So those are our pretend co-vertices. So now this is where it gets a little weird. Just go with what I'm about to do. You will have an entire day dedicated the day after this lesson to do nothing but practice this concept. So what I'm about to do, just go with the flow. Here we go. The next thing I'm going to do, so what I did first is I plotted A and B. just like I did up here. I have my points. I plotted what I needed to. Next, I'm going to, so I'm not going to put a comma. I'm just going to put a number 2. Next, I'm going to draw a dashed rectangle. So I'm going to draw a dashed rectangle. Through my A and B. Okay, let me show you what that's going to look like. So I'm going to draw a rectangle going through A and B. So this is going to be a dashed rectangle. I'm going to stop once I reach this point, and I'm going to go through until I reach where 2 is. I'm going to go all the way down and then all the way across. So I have a dashed rectangle. So now that I have my dashed rectangle, I am now going to, step 3, going to put points on the corners. So I'm going to dot the corners. So on the corners of my rectangles, I'm going to put points. All right, so now this is what our picture looks like. Okay, so now next, what we're doing here, just to give you an idea, is what we're doing is we're trying to come up with our structure for our problems. So I just wanted to let you know that. We're just coming up with our structure. Step number 4. What we're going to do is we're going to draw dashed asymptotes through the corners and 0, 0. These are going to be our asymptotes. That means that our hyperbolas are not going to cross these asymptotes. They're going to go through our corners and 0, 0. So I'm going to take out a straight edge. If you have a straight edge, like a piece of paper or a ruler or the side of your calculator, take out a straight edge. And I'm going to go and draw asymptotes that are going to go through my corners and 0, 0. And this is going to be dashed because this is not part of my graph. It just is the structure, the bones of my graph. Next, I'm going to identify the equations of each of these lines. So the equation of this line, it goes through 0, 0. So that's going to be step number 5. So step 5, write the equation for each asymptote. So I'm going to write the equation for each asymptote. So looking at this asymptote, it's linear. So I'm going to go and find the slope. So I'm going to start at 0, 0. So my b value is 0, and I'm rising 1, 2, 3, and running 2. So my equation is y equals 3/2 x. And this equation, I'm going down 3 and to the right 2. So this equation is y equals -3/2x. So my asymptotes is y equals ±3/2x. I am almost done. I now need to come up with my foci. Your foci, there's going to be 2 of them, one for each hyperbola. Once again, just like with parabolas, foci are the hyperbolas hug the foci. And the foci has an opposite, just like the general equation here is kind of opposite of an ellipse. We're going to be working with an opposite kind of equation for foci. We're still going to use the letter C, and it's still going to be equal to plus or minus the square root. But instead of it being a squared minus b squared, It's now going to be a squared plus b squared. So the way to remember it is these two signs need to be opposite. So if you're working with minus in your general equation, you're going to use plus in your foci equation. If you're working with plus in your general equation, you're going to work with minus in your foci equation. These two signs are opposite. That's how you remember how to do it. So the nice thing here is that it doesn't matter which one you put first. We can put 4 plus 9 or 9 plus 4. It doesn't matter. We're adding, and that's kind of nice. So c is equal to plus or minus the square root of 9 plus 4. And 9 plus 4, that's the square root of 13. And it's always easier to graph decimals, and the square root of 13 is 3.6. So foci are always along your axes, that is your focus. So in this case, it's going to be on the x-axis. So on the x-axis, I'm going to count out 3.6 units. So starting at 0, I'm going to count out 3.6 units. 1, 2, 3, and a little bit more is 3.6. And over on the other side, I'm going to count 3.6 units. 1, 2, 3.6. These ordered pairs are located at 3.60 and negative 3.60. So those are my ordered pairs. So 3.60 and negative 3.60. Now I have everything that I need in order to graph these hyperbolas. Because there's so much setup, I'm not even going to ask you guys for ordered pairs. So this is how you graph it. The vertex is going to be where we're going to start, and I'm going to kind of curve along where the asymptotes are, and I'm going to kind of make it like this hyperbolic, this parabola-looking shape, kind of looking like a sideways U. And here is the other one. So it's going to kind of look like a U shape. So the part of the graph that we actually are absolutely interested in is these hyperbolic shapes, these parabolic shapes. And this is your answer. All right, so I know what just happened is really weird. This is essentially, and I know that I went very slow, but essentially this is what you do. Whatever letter is first, that's where your hyperbola is going to land. It's either going to go to the left and right, or it's going to go up and down. Then whatever is below your positive letter, so in this case 4 was below the positive x squared, we're going to take the square root of that, that's 2, and that's what we're going to count starting at 0, 0. I counted 2 to the left, or 2 to the left and 2 to the right. Then the square root of 9 was 3, and I counted 3 up and 3 down, and I drew this rectangular box going all the way around it. Then I drew dashed lines going through the corners and 0, 0, because these represent my asymptotes and help to guide me as I draw or sketch my hyperbola. Your foci is going to be using the formula that c is equal to plus or minus the square root of a squared plus b squared. The way to remember if it's going to be plus or minus is that it's always the opposite of what your general form is, whatever your general equation is. All right, let's do another example. Here is example number 2. So for example number 2, unfortunately, this is not written in the correct form since it doesn't equal 1. So we're going to divide both sides, every single term on both sides by 16. And when you do that, you end up with y squared over 16 minus x squared over, and this is 16 over 16, which is going to be 1. Show that 1 because that's something that we're going to be using. Equals 1. So don't just make it x squared. That's very important here. Now, because y squared is first, y squared is our winner. Y is going to be our axes that we're going to be focusing on. This means that our hyperbola is going to be up and down. And y-axis is our winner this time around because it comes first. It is our positive fraction, so it's coming first. Center is going to be 0, 0. My A value this time is the square root of 16, which is 4, and my B value is equal to 1. So now I'm going to plot 0, 0, and I'm just going to count. My y-axis, I'm going to count 4 units up. 1, 2, 3, 4. And I'm going to count 4 units down. 1, 2, 3, 4. These two ordered pairs represent my vertices. So my vertices are going to be located at 0, 4 and 0, negative 4. My pretend covertices, do you guys now see why it's pretend? Notice that our hyperbola does not go through these points, yet we need them in order to help us with our structure of the problem. So our covertices this time around is going to be based on 1, and so I'm going to count 1 unit to the right and 1 unit to the left, and those ordered pairs are going to be at 1, 0 and negative 1, 0. My foci, I'm going to be using the formula that c is equal to plus or minus the square root, and I'm simply going to add my denominators together under the root. So that's going to be 16 plus 1, which is equal to plus or minus the square root of 17, which is approximately plus or minus 4.1. And since my axis is the y-axis and hyperbolas hug the foci, so it hugs the foci, I'm going to count 4.1 units vertically. So I'm going to start at 0, 0, and I'm going to count 4.1 units going up. So it's 1, 2, 3, 4, a little bit more, and 1, 2, 3, 4, plus a little bit more. So here's my foci. Those are located at 0, 4.1, and 0, negative 4.1. Now I'm ready to come up with my asymptotes, and so I'm going to use this 5-step process that I wrote out for you down here. We've already plotted your A and B. Now we're going to draw a dashed rectangle through A and B. So here's what my dashed rectangle is going to look like. Next, I need to dot my corners. So I'm going to dot my corners. Next, I'm going to draw dashed asymptotes through the corners and 0, 0. This is going to give me my structure. Take out that straight edge again. If you have a calculator, use the side of your calculator. If you have a piece of paper, use the side of a piece of paper. In your notes, you do not want to be sloppy with this. You want to make sure that you have neat dashed lines. And these asymptotes need to be dashed lines. Everything I'm doing right here needs to be dashed lines. The only part that needs to be solid is the actual hyperbolas. So I'm going to draw dashed lines going through both sets of corners and the center. So we have 2 asymptotes. So now what we need to do is we want to write equations for these asymptotes. So starting at 0, 0, that's my B value. I'm going to rise 4 and run 1. So my equation is y equals 4x. And I'm going to go down 4 to the right 1. So this is y equals negative 4x. So my asymptote is y equals plus or minus 4x. So those are my asymptotes. Now that I have everything drawn, I'm going to start at my vertex, my actual vertex, and I'm just going to follow along, making sure I don't cross. I got pretty close right there. I don't cross my axes. So I'm going to kind of like follow along, making it kind of curvy at the top. So there's one hyperbola. Here's another hyperbola following the axes, making sure that my focus is being hugged. I'm going to use a color just to identify the actual part that was actually my hyperbola. And there's my answer. Okay, so like I said to you before, there's going to be an entire day dedicated to you doing nothing but in-class practice of this concept. So I don't want you to feel too overwhelmed by it. Just take your time. Eventually, you'll get a little bit faster with these. All right, so we have a few more examples, 3 more to be exact, and then we are finished with this unit. So what we want to do now is we want to write an equation of the hyperbola, given that our foci are located at -8, 0, and 8, 0, and our vertices are located at -5, 0, and 5, 0. So writing out our equation, notice that our vertices is at -5, 0, and 5, 0, and they're both located in the x position. Even your foci are located in the x position. What this tells you is that x squared goes first, and 5 will be squared, so that's going to be 25. So x squared over 25 minus, I'm going to write y squared over, and I don't know what that value is, but I do know that this needs to equal 1. And I do know what my foci is. My foci are at -8 and 8. So I'm going to use this 8 and that formula that c is equal to the square root of a squared plus b squared. I'm not going to work with the plus or minus because that's not going to be productive. So just work with the equation with the formula without the plus or minus. So I'm going to write 8 is equal to the square root, and I'm going to write 25 plus, and we're going to call it b squared. We can call it anything that we want. It doesn't matter what letter, but I'm going to work with b squared since that's just being consistent. In order for me to get b squared alone, I'm going to square both sides, and we end up with 64 is equal to 25 plus b squared, and that's because the square eliminates the square root. I'm going to subtract 25 on both sides. And when I do that, I end up with 39 is equal to b squared. I don't need to take the square root of both sides since the number that's supposed to be below y squared needs to be b squared. So that's going to be 39. And this is simply our equation. So now we have example number 4, and we want to write an equation of a hyperbola with foci being at -0, -10, and 0, 10, and vertices being located at 0, -6, and 0, 6. Notice that your foci and your vertices, the actual numbers are located in the y position. So that tells us that y squared goes first. And then what's going to go below y squared is going to be your vertices. Since in this case it's 6, 6 squared is 36. So 36 will go below the y squared. Minus x squared over some number. I need to figure out what that is, but I do know that my equation is supposed to equal 1. So I'm going to use my formula for foci to help me out. I'm going to work with that positive 10. You could work with negative 10, but I don't think that it's going to be necessarily productive. So I'm just going to use 10 is equal to the square root, and I'm going to write 36 plus a b squared. And whatever that is going to go into the blank below the x squared. I'm going to start by squaring both sides, and when I do that, I end up with 100 is equal to, well, the square eliminates the square root, leaving us with 36 plus b squared. I'm going to subtract 36 on both sides, and I end up with 64 is equal to b squared. So 64 is going to go below x squared, and this is my equation. So now we have one last example, and that is dealing with this military plane. It says a military plane is flying along a hyperbolic path with a focus, let me clear this in, let me make sure you guys can actually read this, with a focus that is at 0, 2 square roots of 3, and will go through the point 0, 2. Notice that that 0, 2 is going to be our vertex. The center of the town below the flight path is located at x. Write an equation for the path of the plane, and we want to figure out how high is the plane directly above the center of the town. So we want to figure out what is this ordered pair. So we're going to write an equation, and then we're going to find what this value is. So if I were to zoom into this picture, now we want to write an equation of this hyperbola, and then we want to figure out what this point is. How high above the ground is the airplane? Now, if you look over here, we're going to go over 3, and we want to figure out how much we're going up. So this is going to be the ordered pair, 3, comma, some value. I don't know what it's going to be yet, and that's going to be some y value. So that's what we have to figure out a little bit later. So that's the reason why we have to come up with an equation first. Okay, so based on what we're given, notice that this hyperbola is pointing up. So that tells me that y squared will go first over, well, our y value is 2, and 2 squared is 4. So that's going to be y squared over 4 minus x squared over some number is going to equal 1. And I was given my foci. In this case, it's 2 square roots of 3. So I'm going to use my equation that we talked about up here in order for me to figure out what's going to go below the x squared. So I'm going to write 2 square roots of 3 is equal to the square root of 4 plus b squared. So now, in order for me to get rid of the square root, I'm going to square both sides. Now be careful here. We need to put parentheses around 2 square roots of 3. And then we're going to square that entire quantity. So this is going to be 2 squared, which is 4. 4 times 3, which is 12. So once again, this was 2 squared, which is 4, times the square eliminates the square root, which is 3. So that's how I got 12. Equals the square eliminates the square root, and we're left with 4 plus b squared. I'm going to subtract 4 on both sides, and we end up with 8 is equal to b squared. So 8 is going to go below x squared. Now I'm going to use this equation to help me to find what my y value is. I know what x is, so I'm going to let x equal 3. And I'm going to find what my y value is, and that's going to represent my height. So I'm going to write y squared over 4 minus 3 squared over 8 equals 1. I have y squared over 4 minus 9 over 8 equals 1. I'm going to add 9 over 8 to both sides. And when I do that, the 9 over 8's cancel out, and I'm left with y squared over 4 equals. I'm going to change 1 to be 8 over 8. And 9 over 8 plus 8 over 8 is 17 over 8. Now I have a proportion, and I'm going to use cross product. And when I do that, I end up with 8y squared is equal to 4 times 17, which is 68. Dividing both sides by 8, I have y squared is equal to, well, they both have in common a 4, so this is going to be 17 halves. I'm going to take the square root of both sides and make sure that you put 17 over 2 into parentheses into your calculator, because you're going to end up with y is equal to, you could end up with a plus or minus answer. I'm sorry. You could end up with a plus or minus answer, but it's not necessary this time around, so I'm just putting that out there because we don't want a negative height. So this is going to be y equals 2.92 miles if we were to approximate our answer. And so that's what this height is. It is 2.92 miles above the city, or the town, whatever you want to call it. And that is the end of today's lesson. So we learned about hyperbolas, and like I said, there's going to be an in-class worksheet to give you a little bit more practice on this topic, but hopefully it was not that bad for you. But if it was, please feel free to come and see me after school, or to ask questions when I see you next time in class, or to email me. But otherwise, I hope you have a wonderful day, and I will talk to you soon.